So I'm super excited to talk to you guys today about ozone therapy, all the implications of how it can help keep our pets healthy and all the many conditions it can help treat as well. But first, I'm just going to talk about what ozone is, what exactly is it in our environment, and how it has been used throughout history. So first, let's talk about what is ozone. To put it very, very simply, oxygen is made up of two oxygen atoms that forms oxygen. When we have ozone, it's actually three oxygen atoms combined that forms ozone. Now, ozone is very unstable and highly reactive, which we'll talk about all the implications of that in the later slides. So obviously these oxygen atoms want to normally form into two to form oxygen. So what happens is it actually takes energy to break apart those oxygen atoms, and then they'll restabilize into ozone temporarily. So let's talk about what is ozone's purpose in nature. So we have all heard of the ozone layer that surrounds the Earth. Of course, that's out in a stratosphere. So this actually forms naturally through the UV radiation of the sun hitting the oxygen atoms, so the two atoms, and breaking them apart, and they reform as ozone. So it's a constant cycle of the UV radiation hitting oxygen and reforming into ozone. And this layer is meant to be there to protect us from those high ultraviolet radiation. And this is where it gets really interesting. So nature actually uses storms, the lightning from the storms, to create ozone, which detoxifies and purifies the air. So unlike the ozone layer where the sun is using the UV light as energy to break apart those oxygen atoms, a storm is using those lightning bolt energy to break apart the oxygen atoms to reform ozone. This diagram here is just simply demonstrating how the lightning is using its energy and the sun's UV rays are using its energy to break apart those oxygen molecules and then forming ozone. So something that's pretty neat is you might notice a certain smell in the air after a storm, and that clean, fresh smell, that is actually ozone in the air. So again, what happens is that lightning comes down, strikes through the air. As it strikes through, that energy breaks the oxygen apart and reforms ozone. Because that ozone is highly unstable and reactive, it's looking to quickly bind to another molecule. And often that other molecule is going to be pollution. So then what it does is it actually oxidizes that pollution in the air, re-purifying the air. This is pretty cool. And then that converts it back to breathable air. The interesting thing is the ozone uses the same reaction with chemicals, bacteria, molds, and odors, which we'll talk about the implications of that later. And once it does that, things are no longer toxic. It can kill viruses and bacteria, which is pretty neat. So ozone can sometimes get a bad rap because of we hear about the ground level of ozone. So this does form usually between reactions between air pollutants, volatile organic compounds, and nitric oxides. Now those volatile organic compounds, those come from our chemical plants, gasoline pumps, oil-based paints, auto body parts and print shops, different sorts of factories and such like that. The nitrous oxide also comes from when we have high temperature combustion. So these pollutant chemicals will react with oxygen in the air and cause what we hear of the smog. We often hear about this in California and LA, the big cities. When you have lots of these pollutants going in the air, it will form these smogs. So smog is a combination of all those pollutants in the air. Ozone levels are within that smog, and ozone tends to get a bad name because scientists use the ozone layer to tell exactly how high the other pollutants are in the air. So it's not that the ozone level is toxic, it's actually that all the other pollutants that are in that smog are much more toxic than a high level of ozone. But ozone usually gets a bad rap because we always read it as the ozone levels. but it's actually those other pollutants that are very toxic and harmful to our lungs. So don't get me wrong, absolutely ozone can be too toxic if it's too high of a level. However, we are using a medical grade ozone that is purified, so it does not have any of the pollutants we associate with the smog. It is pure oxygen. However, but at too high of a level, it absolutely could be toxic. However, that is no difference than our vitamins, medications, all those have a safety range. They have a safe and a toxicity. That's the same with even food. You could eat too much of a food, it could be toxic. Same with alcohol consumption. This is no different. Even oxygen has a toxic level. If you were to breathe pure oxygen, it would be harmful for your lungs. The oxygen in our air is only about 20% oxygen. So ozone is no different. There's absolutely a safety margin and there's absolutely a toxic margin. And we are only using it within the safety margins. So ozone is not new. It has been around for almost 150 years. You can see through the dates here the different implications that they used throughout the 150 years. Started using it as disinfectant, water sterilization, obviously an antibiotic. They started using it during the war to treat wounded soldiers. So there's been a lot of implications throughout the 150 years that we've realized it can be used for. So interestingly enough, ozone was first discovered in the 1830s due to the odor that ozone creates. This scientist realized that he'd smelled a distinctive odor after a lightning storm as while he was running some of his experiments with high voltage energy. So to break down how we use it today, other than talk about medical purposes, we have known it as a very potent sterilizer. So it's obviously often used to control bacteria, viruses, and odors. With its sterilization properties, we've used it all over the world to purify water. We've used it to sterilize planes in the interior. You might even notice that smell sometime when you board on a plane. We've used it to sterilize medical equipment and facilities. Pretty much any indoor facility can be sterilized with the use of ozone.